So 8.11 volume with the washer method for revolving around the X or Y axis. So this is very similar to volume with discs, except you have to subtract out the part that's going to be missing. So basically our formula here is going to be V equals pi, and then the integral with your bounds from A to B of capital R squared minus lowercase r squared. And then it's going to be dx if you're revolving around an axis parallel to the x-axis, or dy if it's parallel to the y-axis. So when you look at these, I think it always helps to just sketch a quick graph. So we got negative x squared plus 4. 1, 2, 3, 4. You can graph these on your calculator as well. And it doesn't have to be anything great, but just to give us an idea. We have that, and then we have x plus 2, which is going to look like that. And it says from x equals negative 2, and negative 2, if you put that in, would be negative 2 plus 2. That's going to give you y equals 0. That's right there. If you put negative 2 in here, you're going to get 0 as well. So technically this point should have matched up, but we're going from there to x equals negative 1, which would be somewhere around here. And so we're taking this piece, and we're revolving it around the x-axis. So it's going to go around this way. So this piece, and if you think revolving two discs before, the big one is going to be this. This is going to be the big one. That's this. All right, so that's negative x squared plus 4. So that would give you, dx from negative 2 to negative 1. That would give you the volume of the large disk. And then we need to subtract out, like this, that area. And that would be minus, and that's this x plus 2 squared. And all of that, of course, dx. I wouldn't do anything else on this one. It's simplifying. If you do anything like that, it's just going to get more complicated. So I would just go ahead and type this in the calculator as it is, just making sure that these bounds are x values when you're rotating around the x-axis, and you've got dx back here. So when you do that, you're going to get the volume using the washer method to be 16 fifths pi, or 10.053 about. So on 36, it doesn't give us anything, but we've got 1, 2, 3, and this is going to do that. That's this one. And we've got x squared plus 3. That's going to do that. So they're going to intersect at 0, and then whatever this is. And we're going to take this and rotate it that way. So the first thing we need to do is figure out where that intersection point is. So if I do square root of x plus 3 equals x squared plus 3, I basically get square root of x equals x squared. Hopefully we can figure out that it's going to be 1. But otherwise, if we square both sides, get x equals x to the fourth, and then we can get 0 x to the fourth minus x factored out, and you get x cubed minus 1. So you get x equals 0, and this is going to be x cubed equals 1, which is just going to be x equals 1. So our bounds are going to be 0 to 1. You could graph it on the calculator and use the intersect function to find that as well. But that's how you would do it by hand. So let me get rid of this. And I got rid of too much, but that's okay. So we know our volume here is going to be the big one, and we were 0 to 1. The one that's on top, the bigger disk, is going to be the square root of x plus 3 squared. I forgot my pi. I need that pi out there. Minus the smaller disk, which is going to be the x squared plus 3 squared dx. And again, just to kind of review, putting that in, we're just going to go to our calculator. There's no trig in this, so it doesn't matter what mode we're in. We're going to go down to integration. Oh, I always forget this. Let's put pi in first. Then let's go to integration. And we're going 0 to 1. And we need parentheses because we're doing multiple things. So square root of x, move out of that radical, plus 3. Close our parentheses, squared, minus another set of parentheses, x squared plus 3, close our parentheses, squared. And then if we go out here, make sure we're doing dx because we are rotating around x-axis. Give it some time to work. And we get v equals, let's bring that back up, I didn't even look at it, 7.2257. If you evaluate it without the pi and then add the pi in after, you get 23 over 10 pi. So that's the volume for those two, and 35 and 36 are rotated around the x-axis. So that makes a big difference. 37 and 38 will be rotated around the y-axis. So our bounds are going to be y values, and we're going to differentiate with respect to y. So, and this is telling us we're going from y is 0 to 1, so it kind of gives us a little bit of help. We know that v is going to be pi, and these are y values now because we're rotating around the y-axis. And if we're doing 0 to 1, sometimes it's just easier to plug in a value. So if I plug in a half plus 5, so that's going to be 5.5 for this one. And then if I put in a half squared is a fourth, negative a fourth, that's going to be 6 3/4. So that means this is going to be the larger disk. So that's the one that goes first. So we're going to have negative y squared plus 7 squared minus the other one, the y plus 5 squared. And this is dy. And just plug that straight in the calculator again. If you put the pi in there, or I'm sorry, if you don't put the pi in there and like to have it afterward, it'd be 71 over 5 pi, or it's about 44.611. Remember, those bounds are y values, and we're checking to see where it's greater in that range, and that's going to be the first one. So here again, we're going to revolve around the y-axis. And I know because it's giving me functions in terms of y and bounds there. So it's going to be -1 to 1. If I put in 0, because that's in this interval, -1 to 1, if I put in 0, I get 7 over here and 5 there. So this first function is the one that's further away from the axis of rotation. And it's greater than this one, so we're going to subtract the -y plus 5. That's running out of room, but I need a dy on there. And again, plug this in. If you evaluate it without pi, you get 192 over 5 pi, and that's going to be about 120.637.